also from my side. Topic of today's presentation is an AI-supported technology to get a better overview of the battery recycling topic. Just a few more sentences. So I am very well, I feel very well introduced, but just a few more sentences about my company, TIM Consulting. We are Stuttgart-based boutique consulting company, specialized in topics around technology and innovation management. Boutique, just a fancy name for being small and specialized. So we are at the moment 12 people of different backgrounds and different expertise, and have a vast network of partners and experts above that. 2 different universities and other friend companies like Rule, for example. That's how we got in contact here today. So AI in technology and innovation management is a topic that has come to us more or less by chance. So we are users of AI technology now for many years, and just a bit before the big media hype started to develop our own tools from the humble motivation of just bringing ourselves up to the state of the art, but very quickly discovered that there are so many possibilities out there with these new large language models that we are now working very hard to develop these new tools. So this webinar has 2 goals. So first of all, as the title says, I would like to present to you some interesting findings on a brief analysis on battery recycling of scientific papers and patents. And with this, I would like to also showcase to you some application fields of these new large language models that everyone reads in the media about. So as there are a lot of people in the room that have an immense amount more of knowledge about batteries than I am, and of course fully aware that what the motivations for battery recycling are. Just some brief sentences. So it's a resource topic. So for example, with lithium-ion batteries, there's materials used that are conflict materials, like cobalt, for example. They are brought from the ground often with child labor, and the resources help more the local warlords than anybody else. And there's also the topic of scarcity. So for example, when you look at lithium, the lithium demand exceeded the lithium supply now already 2 years in a row. Although the production capacities were increased by 180% since 2017, and now we have this push not only through with batteries in our everyday life and many products, but also in increasing demand from electric vehicles. The recycling of materials could be an important topic to conquer these challenges. So that's the basic motivation to find out what's going on in the research and in the patenting landscape. And we will start with the. Now this is interesting. Okay. We start with the research landscape, and I will show you first the results of our quote-unquote old AI technology. I basically created a data set with just the words battery and recycling. So every research paper that has battery and recycling in their title or abstract is listed here. This resulted in nearly 4,500 papers from the last 10 years, and as you can see, there's a very nice close to exponential growth in the publication, which indicates clearly that there is a lot of attention growing in this field. Of course, 2023, as this is not finished yet, has not risen up to the start, but as now a bit more than half a year is through, I think we can extrapolate that the 2023 publication numbers will already exceed 2022. When we look at the origin countries of the research institutions publishing these papers, we see, as maybe some of you have expected, that a large amount, close to 50% of the publications come from China. Followed by the US, and already very far behind my home country, Germany. Our artificial intelligence analyzes the papers and shows a cluster analysis. Every dot you see here is a research paper, and the geographic distance between the dots indicates the similarity of the papers. And via a k-nearest neighbor algorithm, the clusters are formed, and so we have the possibility to derive insights about the topics and about the trends from this large number of papers without reading all of them, basically. So if we look over the list of clusters that were derived, we can clearly see so that there are some meta clusters around the topic of materials. So lithium and cobalt, organic materials, graphene, graphite, rare earth, lithium iron phosphate, and zinc. Also, there are clusters for you guys who are interested in the process technologies. So the actual recycling methods. So we have leaching and thermal process like roasting, pyrolysis. And a very small cluster where there is bioleaching put up separately, also very interesting. And also you can see very clearly that there's not only technical aspects, but we also have some administrative papers that also use the terms battery and recycling, but deal with life cycle assessment or with government policies and subsidies in the topic of battery recycling. As scientific papers have a lot of metadata, like the publication date, we can also do a timeline analysis where we split the data set, in this case, into 3 buckets. And then we can see how the different topics develop. So, for example, you can see the topic of lead. In this case, there are a lot of studies on the effects of lead exposure from battery recycling, as lead is quite an older technology, a very ripe technology. In the battery topic, you can see here that this is a topic where there's a steady stream of publications. You can see that there's, for example, in the topic of organic materials, there's a large growth in the recent years with publication activity. So the bubble size indicates the amount of papers in there. And you can also see that there's a lot of papers that just came up recently in this area. So, for example, all the administrative papers on government policy and subsidies just came up recently, as battery recycling came up on the agendas of the government bodies. Just picking out one for the sake of a bit more of a detailed example, I picked out the cluster of electrodialysis and membranes and looked at the papers, which were quite interesting because there's electrodialysis is a topic that is quite well established, for example, in the areas of water purification and wastewater treatment, desalination, and so on. But is as you have seen on the slide before, is very young to the area of battery recycling. So there are some papers now on separation of materials from waste batteries. There's snuck in some papers that are not originally on battery recycling, but on using so deriving lithium from seawater, or which is also very interesting, to regenerate sodium sulfates from production waste from the actual battery production side, but not the battery itself. And this is also a very interesting example to show you the limits of this old technology, as this technology only compares the word count of each word. It cannot distinguish whether a paper speaks about membranes that are used in electrodialysis process or membranes that are used in batteries. So these are here, this is a case where the limits of technology are seen quite well. But as this is clustered into one cluster. But I found this also quite interesting, that there are some interesting membrane technologies to be used in lithium-ion batteries, where you can, for example, use recycled cigarette filters to create a cellulose acetate membrane, or you can create membranes from eggshells, and so on and so forth. So for me, at least, that was something quite new. With the limits of this technology, you can easily imagine that a better technology allows a better, more potent views, which of course everyone knows from the shown example of the Hubble telescope versus the new James Webb telescope, which allows a lot more detailed and better views of the galaxy. With our new technologies, we are using, for example, the possibilities that we are not just comparing words to each other, but every word is embedded into its context. So when we, for example, say the word well, now I can't come up with an English example. I just remember the German ones. So every word is told in its context. And if you say, for example, you have a bank, the word bank in a text, then you don't know if it's a river bank or if it's the bank where you can put your money. And with this new technology, it has a better understanding of the position in the text. Above that, as you can see here, I think this is one of the most impressive charts out of all of this AI discussion. The results I just show you work with this TF-IDF algorithm, and you can see clearly that just a few years ago, the full effect of the exponential growth of the complexity and therefore the power of the systems came through immediately. And now, if this still goes on, we can expect very interesting things. So our new technology, with the working title Cumulus, uses this new OpenAI technologies we are currently working with GPT 3.5 to make a lot of better analysis out of this data. And also we are not using the keyword specifically, but we are also able to use the via a named entity recognition algorithm, different sorts of topics that we can derive from the text. So the keyword analysis has its limits just by itself, and we are able to identify automatically in a text technologies, application fields, functions, and quite recently we are experimenting with materials. Which I thought could be interesting, as this is basically a presentation in a materials community. So we are experimenting with this around this PFAS issue that some of you might already heard of, and this is just a brief disclaimer. This is work in progress, so if you see something here that is that does not fit perfectly in, this is just a status of our current technology that we are continuously tweaking, but I did want to put in some example with a materials cluster. So as you can see here, the clustering now is mostly based on only the materials topics, and what we can then also do, apart from this analysis, we can then look at, especially with the research papers, at the corresponding institutions and see which research institution has the most activity in which cluster. So I handpicked just a few out. So for example, we have the United States Department of Energy, which has a strong footprint in cluster 5, lithium-ion battery materials recycling, or for example, German Helmholtz Association is also strong in a similar field. Switching over to the patents. Just to be conscious of the time, I'm really sorry to just be able to give you a quick overview about some of the topics and not an in-depth, in detail analysis. So looking at the patents with the same search strings, so patents that have battery and recycling in title or abstracts, we came up with over 7,000 patents, but not in the last 10 years, but in the last 5. So in half the time, there are close to double the amount of patents than scientific publications. I don't know what to take from this, but I thought this is quite an interesting information. Now seeing the cluster analysis, again, not based on the keywords, but now based on the functions. And what we can see here is quite interesting, that when you do a data analysis, you have also the issue of how to cut the data set depending on your search string, so that you don't have too many interesting results left out. Then your search string is too narrow, and if it's too wide, then you have too many things inside your data set that you don't want to have there. So these are called the false positives. And with this analysis, this is a bit less of a problem, because this now sorts out a bit easier. So for example, if you look at the cluster 8, energy efficient HVAC systems, this is a cluster basically comprised of patents that work with around heat recycling or energy recycling, and mention mention a battery in some capacity. I looked at some of them. So for example, some of them speak of a battery sensor, a battery powered sensor that they use. in this capacity. So this is a good way of cleaning the data. But now coming back to the actual interesting patterns on battery recycling. Maybe just one more sentence on this. I mean, we all know that it's more or less a sport with many people to write the patent as cryptic and as difficult to understand as possible, so that it's hard to find for the competitor, and it leaves a lot of leeway for any discussions. And this technology now has the possibility to sort out this mess a little bit. Another presentation form that we have is this radar presentation, and you can now see we have the clusters as I've shown you as the main topics, and every cluster falls into more subclusters, and these can be analyzed also with the metadata. So the further away a subcluster is from the center, the younger the average publication year of the patents in this cluster are. And one thing I found very interesting was this small cluster right here, that is on average younger than any other cluster in here. And I was a bit irritated when I read the automatically generated title of a short circuit discharge reaction. So I looked this up, and all of these 20 patents are from a Chinese inventor called Yin Heng, and they are all about a battery recycling method where you use low energy plasma to discharge the battery via short circuit and use this energy to heat up the plasma to use then later in the recycling processes. Quite an interesting guy. So just not a company, an individual person that has in total about 80 patents, and they all are more or less around plasma technologies and not mostly on batteries, battery recycling. When we look at the top applicants, it's from a Western perspective a bit sad view. So we see Mr. Heng right here with the 20 patents, and if you want to look at some of the Western companies, even some of the non-Chinese companies, we have to look very long and hard. There's in the top 20 basically 3. So very nice for me. 2 of the 3 are from Germany, and 1 is from South Korea. The first US American patent applicant with 9 patents is a company called Aqua Metals. So also not one of the big players. And from the German point of view, it's also a very interesting topic, because we have this very large, very well-established company, BASF, from the chemical sector, and we have a very new startup, Duesenfeld GmbH, which is a spin-off of Technical University of Braunschweig, and so they took some patents that came out of the research of the Technical University Institute, and founded this startup with a combined process of mechanical thermodynamic and hydrometallurgical recycling processes, where they say that they can increase the recycling yield on a battery system to 90%, but this is of course not only the battery materials, but also aluminum, steel, etc., etc. Yeah, so these were just very few snippets of insights from a battery study, a very broad overview of the possibilities that the tool can give. Normally, when we use this in a project, we have iterative sessions with the customer to tweak the question or the data set, or the focus that we can put on the data again to get more in-depth insights into specific clusters. But as I'm only seeing you today for the first time, I had to come up with some interesting insights myself. I hope that it was very interesting, and I could give you some interesting points and showcase you the possibilities of this new AI technology that is best described, in my opinion, with a quote from Sherlock Holmes: "The world's full of obvious things which nobody by chance ever deserves." So thank you very much, and I'm looking forward to your questions.
Thank you, Philip. It's a really interesting presentation. I appreciate it. I guess with that, we can open the floor to questions. If anybody has questions they want to ask, or if there's any points that maybe Philip highlighted and maybe skipped over, if you want him to go back to, that's also an opportunity. Feel free to raise your hand. I've opened everybody's mic. You just have to take yourself off mute, or you can type a question in the Q&A box at the top of the screen as well if you've got a question. I guess what maybe some of the others are thinking. So you mentioned just doing a quick overview for the sake of presenting the methodology and the approach, but maybe you could share, if this was a project, if you can go back to, or show an example of maybe how you could go a little deeper, right? If I'm your customer and we've done this as round one, what could you envision of going deeper? What else could we learn if we went a little deeper with the analysis?
Yes, so the cluster analysis is, of course, basically a way to find the most interesting aspects in a very large data set without the necessity to read in depth all of the data set. So for example, when you want to look at patent applications on battery recycling, then you have the corresponding IPC subclass. But as the IPC subclass system is not perfect, and there's many ways to sort your patent into a different IPC subclass, and many companies do this on a professional scale to hide their patents. You cannot be sure if you have seen all of the relevant patents. So we take a bigger data set, and then with the cluster analysis, we can say, okay, let's pick out clusters 1, 3, and 7 to look at this in more detail. Maybe if the data set is big enough, we can do just the same method with a reduced data set and get more in-depth insight into this clusters. So that we have basically a layered set of different clusters. So if we do this 2 times over, of course, we don't have a cluster and a subcluster, but we then also have subclusters of the subclusters. So we get more depth into this area. Also, we can use this for competitor analysis. I've shown you the heat map with the research institutions. Of course, this is applicable for when you use patents, then it's more interesting to look at companies that applied for patents. And when you then cross this also with the timeline, you can see Well, how does the patent activity evolve over time with my competitors? In what subclusters are they maybe applying for more patents? In what subclusters are they maybe applying for less patents?
Okay, so almost like a competitive analysis. You could use it, to supplement a traditional competitive analysis, competitive landscaping. You could use this as a tool to also look at the technical aspects of that as well, maybe what they're already working on from an R&D perspective.
Exactly, but of course only in technological fields where patents are a thing.
Okay, understand. Anybody else have any questions I'd like to ask? Yeah, I've got another one. So we talked about the competitive analysis, using this tool. I mean, this is a tool, right? And so understanding all the different use cases or how we could use that tool is always important. You showed Duesenfeld as a small company. To me, that if I put my investor hat on, it could be used also to landscape for potential startups in certain areas for acquisitions, and maybe even from a business development perspective of finding people that are active in a space that you may want to partner with or joint venture with. I mean, is that an application that can be used for as well?
Yes, definitely, and we actually use it in a field. Not that often to identify startups, but because we have not found a company yet that wants to do this with us, but this would be perfectly possible. Especially, I find this interesting with startups, where especially technology startups are founding their company not around a product but a technology. So, for example, now with this Duesenfeld GmbH, they took some technology patents and are now trying this in the battery recycling sector. But as we all know from Eric Ries, startups put up hypotheses, and sometimes they work and sometimes they don't. And when they don't work, they take that technology and try to apply it on a different field. And we can, with our technology, with an intelligently designed analysis, shortcut this process, that we describe the data sets based on abstract competencies. And as we do a full text analysis, to design the search string, this is also possible, and then we can say, okay, let's find all startups in all companies that write patents about torque and plastics or polymers, for example, and then let the algorithm figure out in what fields of application they use this competency. And so you have the possibility to identify a different set of companies or startups that you cannot replicate with a single Google analysis. And of course, as this is patent based, it's also completely fact based, and you have the IP issue already figured out, as you can only find guys that have patented something.
Anybody else have any questions? I'll keep asking. One other one. It's more of an AI-based question. So you mentioned that it's based on ChatGPT or 3.5. Where do you see the release of 4.0 factoring into your product roadmap with Cumulus?
So we are very opportunistic in this way. So we could have already switched over to 4.0. But our technical experts tell me that the API does not yet run so smoothly as 3.5. So and the results were that we could derive from the 4.0 API were similar. So there's at the moment no necessity for us to upgrade. However, as you can already hear it out, we have designed this system, the system interface, very open, so that we can easily switch over to a different version, because as you've seen with this exponential curve, the development is so fast and so amazing that we try to design the outward going layer perfectly open to integrate different systems that then work well with our AI systems, analytic AI systems that we use for ourselves. Also, there's another issue. So, for example, maybe you've heard that GPT is at least partially banned in Italy, and so with the European Union discussing regulations of AI, etc., we have to, of course, be prepared for this, so that we can, let's say, maybe switch over to the German company Aleph Alpha if there is some kind of issue with OpenAI in the future.
Interesting. Okay, thank you. Well, I guess if there's no other questions, we can probably wrap things up today. Wanted to thank everybody for tuning in today. We know time is precious, and so you took time out of your days to visit with us and participate in today's webinar. So we do appreciate your time. And many thanks to Phillip for all your hard work preparing today's presentation, and for the support of Tim Consulting. I think it was a good webinar, good overview on the topic as well. For those of you on the call today, feel free to reach out to Phillip, Tim Consulting, engage with them if you got any other questions as well. And then once again, as I mentioned in the opening, today's webinar is being recorded and will be made available on the Modulus platform. So we're creating a specific group, which we call channel up there, if you're familiar with Modulus. For the speaker series, we'll post the recording, and then you can certainly use that as a forum to ask questions if some come up after the call and you want to pose it to the group, make comments. That's the place to do that as well. And certainly Phillip's on Modulus, and of course on LinkedIn if you want to reach out to him those ways as well. And then I guess, Phillip, maybe the next slide or the one before that. Yeah. So for those of you that may not be on Modulus, it is free. It's a platform you can join. Just go to onmodulus.com and you should be able to enter your information and get in there as well. So with that, I do thank everybody again for your time, and look forward to hopefully seeing you at another one of our webinars, and do appreciate your participation today.
Thank you very much. Have a nice day. Bye-bye.
See you, everybody. Thank you.